Welcome back to day 4 of chapter 1. We are still in section 2.2. We're looking at histograms and using histograms wisely today. And by the end of this lesson, you will be able to make and interpret histograms of quantitative data, compare distributions of quantitative data using histograms. This is an assignment that you should attempt after this lesson. All right, let's get started. Now there is a warm-up that we will be completing at the start of class. So save this for when we get into class. Let's dive into 1.2, day 2, displaying quantitative data with graphs. Now, you can read much of this information on pages 40 to 46 in your textbook, and we're starting out with an example. So example 1, the following table presents the average points scored per game. So that's where we're getting PPG, points per game, for the 30 NBA teams in a recent season. Make a stem plot to display the distribution of points per game, then make a histogram. All right, so to start with, we're going to start off with the stem plot. So we have the PPG going down here. And when we take a look at these, I can see that the lowest numbers appear to be in the 93s, so like 93 point something. There doesn't appear to be anything 92, so I'm going to start with 93. And then it goes all the way up to 106 point something. All right, now you're going to have to write a little bit small. All right, so I started off making a stem plot without all of the leaves organized just so that I could get all of these in here. And I put down my stems from 93 to 106, and I'm using my decimals, my tenths place, as my leaf. So everything in front of the decimal, the ones, the tens, and the hundreds place, those are my stems. The decimal following, the number following the decimal point, are my leaves. So I have 93 to 106, and I just started reading these. So 98.0, I went ahead and put a 0 here next to 98. 96.5, I put a 5 next to 96. 96.9, that's where the 9 next to 96 came from. 93.4, I put a 4 next to 93, and so on. I just went down the line, putting all of my numbers in here. I didn't care about the order because I can always rearrange the order afterwards, and that makes it much quicker. You'd have to get everything in order at some point. It's faster to get everything organized, and then you can just reorder your leaves. All right, so for 93, I had 3 2s and then 2 4s. So that's why I have 3 2s and 2 4s here. Then I had 2 1s and then 7 and 9. And I had a 2 and then a 7, 5 5 and then a 9, a 2 and a 5, 0 0 and then my 9. I needed to skip over 99. I didn't have 99 point anything. However, the 99 still needed to be there for this to be evenly scaled in the stem. Treat this like a number line that you're scaling. You wouldn't skip a number on a number line. You don't skip a number in your stems, even if the stem is empty. All right, so 99 is still there, but I leave that empty space to show the gap. And then I have 100.0, 100.2. In my key, I show that 97 with a line and then 2 represents a team with a 97.2 points per game. All right. Now, before we make a histogram, let's discuss what one is. So a histogram shows each interval of values as a bar. The heights of the bars show the frequencies or relative frequencies of values of each interval. Now, keep in mind, each of these numbers were reported as actual individual values that we could take the average of. A histogram just helps us figure out the frequencies or relative frequencies within an interval of values, but we're not treating these like categorical data. A lot of times categorical data is gathered, the numerical data is gathered within the categories, or it's turned into categories later. Right now, we're still looking at these as individual data points. We're just making a more condensed graph than a dot plot would be, or than our stem plot is. So, a word of caution. Now, you can make a dot plot or a stem plot first to help you plan out your histogram. And a word of caution, the choice of intervals in a histogram can affect the appearance of a distribution. Histograms with more intervals show more detail, but may have a less clear overall pattern. So, you want to have enough bars in your histogram that you can actually see the overall shape, but not so many that you can't see whether it's skewed or symmetric. Now, how is a histogram different from a bar chart? I was touching on this earlier. A histogram displays the distribution of a quantitative variable. Its horizontal axis identifies intervals of values that the variable takes. A bar graph displays the distribution of a categorical variable. Its horizontal axis identifies the categories. Be sure to draw bar graphs with blank space between the bars to separate the categories. Draw histograms with no space between bars for adjacent intervals. The only time you're going to have a space is when there is a bar that has a height of 0. The bar is still there, you just can't see it because it has a height of 0. So no space between bars for adjacent intervals. Be very careful with this. I know that some of you may have seen histograms with spaces between the bars in the past. Those were incorrect. All right, the internet is flooded with incorrect examples of histograms. Please be careful. You will have points off if they ask you for a histogram and you leave spaces between the bars, both on the AP test and on my test. Now, how to actually make a histogram. Step 1, choose equal width intervals that span the data. 5 intervals is a good minimum. I often go for 7 or a few more. 5 is kind of the minimum that you need to be able to see the shape. If you have 4 bars, you can't really see the shape very well. So you need, at minimum, 5. Step 2, make a table that shows the frequency, the count, or the relative frequency, percent or proportion of individuals in each interval. Put values that fall on an interval boundary in the interval containing larger values. I'll explain what that means here in a minute when we have our visual. Now, step 3, draw and label the axes. Remember, draw and then put titles on your axes. That's what label means. Draw horizontal and vertical axes. Put the name of the quantitative variable, your title, under the horizontal axis. To the left of the vertical axis, indicate whether the graph shows the frequency, count, or relative frequency, percent or proportion of individuals in each interval. Step 4, scale the axes. Place equally spaced tick marks at the smallest value in each interval along the horizontal axis. On the vertical axis, start at 0. Very important. You must start at 0. If you don't, you are going to have a deceptive graph. There's no point in making a graph if it's not going to show you what you need to see. And place equally spaced tick marks until you exceed the largest frequency or relative frequency in any interval. Step 5, draw the bars above the intervals. Make the bars equal in width and leave no gaps between them. Be sure that the height of each bar corresponds to the frequency or relative frequency of individuals in that interval. An interval with no data values will appear as a bar of height 0 on the graph, meaning that you won't necessarily see the bar. It's still there, but you don't necessarily see it because its height is equal with the x-axis, with the horizontal axis. All right, so continuing our example from example 1. So we're going to make our histogram. Now, I chose to use intervals from, basically intervals of size 2. So I took a look at this and I decided if I included all of the numbers in 93 and 94 as one interval, then I would have 1, 2, 3, 4, 5, 6, 7 bars. All right, that's pretty decent to be able to see the shape of a distribution. All right, now in order to do this, I'm basically taking numbers from 93.0 all the way up to 95, but not including 95. And that's why I have this written out the way that I do. So my interval from 93 to less than 95, so basically 93 to 94.9 based on the way that the points per game were written out, would be included in this. Then 95, so 95.0 starts the next interval. And I'm going all the way up to 97, but not including 97, so I stop at basically 96.9 with the way that these numbers were written. And then 97 starts the next. Now, if I had numbers that went more than one decimal place, I could have up to 96.9999999 all the way to infinity. But the moment I tipped over into 97, it would go to the next interval. So as I counted these up, I had 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in my first interval. I had, let me go ahead and put these under each other so we can see them side by side. I had 1, 2, 3, 4, 5 in my second interval. I had 1, 2, 3, 4, 5 in my third interval. Nothing right here, but I have 1, 2 for my second interval. 1, 2, 3, 4, 5 for my next one. Only 1 in my sixth and 3 in my final one. That's how I got those frequencies. Now, you already have the axes in your notes. What I went through and I did was I equally spaced out my tick marks. Now, I don't actually need these tick marks in the middle. I just did that to be able to make this as equally spaced as possible. And notice that from 93 to 95, 95, 97, 97, 99, and so on, it's equally spaced so that my bars are equal width. And then I started at 0 here and scaled myself upward so that I could include my top frequency of 9. I could even include another frequency of 10 if I so wish. I labeled points per game down here. And then I labeled number of teams on the side to show that this is the frequency. This is the count, not proportion or relative frequency, right? This is just a frequency histogram. If I were comparing 2 different years, then I would have a relative frequency histogram. Right, so from 93 to less than 95, I had a frequency of 9, so my bar has a height of 9. From 95 to less than 97, I had a frequency of 5. 97 to 99, I had a frequency of 5. From 99 to 101, I had a frequency of 2, and so on to create my histogram. Now notice that this is a right skewed distribution with the main peak between 93 and 95. So this is skewed to the right, because if you take a look at, see, there were 30 teams here, so 15 would be our middle. The 15th team would happen right in the 97 to 99 section, so the middle would be right here. The right side of this graph is much longer than the left side when you take a look at the median value. Now, why would we prefer a relative frequency histogram to a frequency histogram? When are we actually going to take that extra step and calculate percents or proportions? We use percents or proportions instead of counts on the vertical axis when comparing distributions with different numbers of observations. And some common histogram mistakes would be using the observation number on the x-axis and the value of the variable on the y. So basically switching these is a common mistake. Be very careful not to do that. And forgetting to label or scale your axes. Now here you can see word length in journals versus magazines by frequency versus percent. There's a different number of journals compared to magazines. So these counts are actually out of different totals. When you take them out of the same totals, these graphs appear much more similar than they did previously. And you can actually see that there's a much higher percent right here for magazine versus journal, whereas if you just look at the frequency, the comparison wouldn't actually be the same. That's why we often prefer relative frequency over frequency when we're comparing 2 different distributions. Now, if you need directions for how to get a histogram using the calculator, right, we would turn our calculator on. And if you go to the stat section, so go to stat, hit enter on edit. So edit is option 1 right here. And I'm going to clear this out. So to clear, go up to the list title. So notice I went up to the top there, I hit clear, hit enter, and that cleared out all the numbers that were in there. All right, so type your data into the single list. If you have a frequency table, use a second list for the frequencies. Now, I recommend just typing in all the numbers as they appear. So I would type in all 30 of these numbers one at a time. It's like 98.0, 96.5, enter, 96.9, enter, and so on. And then when you want to actually plot a histogram, we hit second and then the y equals button. Do you see how it says stat plot right up here? All right. So if I hit second y equals and I go to stat plot, hit enter on that. You want to make sure your plot is on. You want to go to the third option. Data is in list 1. The data axis is going to be axis X. This one doesn't necessarily show that. The updated calculators have that, like the ones in our classroom. There we go. You need to actually hit enter for that to select. So X list is list 1. Frequency is just 1. We don't have a frequency list. You can identify the color that you want this to be in. And then once you have all that set up, you go to Zoom Stat. All right, so Zoom is found right in the middle here, as you can see right there. And then option 9 is Zoom Stat. Now, setting up the window, all right, your X min, your X max should be your smallest and largest values on the horizontal scale. That determines the start of the first bin. X scale determines the width of each bin. The Y minimum, Y maximum, the largest and smallest values on the vertical scale, determines where the tick marks occur on the vertical scale for the Y scale. All right, then you can press graph and view the histogram. If you click trace and use the arrows to view the information about each bar on the histogram, this will take you through basically how to use your calculators to help you make these graphs much more quickly. All right, that way you don't have to do all of them by hand. As always, please try our assignment, and I will see you in class. We'll do our warm-up when we start out class tomorrow.